I believe this is, or did we get, because X reflection should be after. Because I know we did these. Oh, we stopped on 6? Okay. So this is where we stopped off yesterday with our horizontal stretch and shrink and vertical stretch and shrink. And applying these transformations to the function. Now, with these here, we do have the general forms that we've been going over. Horizontal translations are our f of x minus h, and we use this form if we're moving the function to the left or right, and h is the amount that we are going to move it left or right. Then we also have our vertical translation is our f of x plus k. And this is how far we're going to move the function up or down, where k is the amount that we're moving the function up or down. And f of x is the function we're applying it to. The next thing we covered was reflection. Now, if it is across the x-axis, it's our negative f of x. And if it's across the y-axis, it is f of negative x. As we had these here. And the ones we had yesterday are our vertical stretch or shrink. And the formula we had for this was a times f of x. So we take whatever that stretch or shrink amount is and multiply it by the entire function. And the last one we had was horizontal stretch or shrink, which is our f of.
Your attention, may I have your attention, please? It's now time to release the softball girl. It's now time to release the softball girl.
And we need to make sure to flip, not two p's. Sydney? Yeah, he's not. So, the last thing is with the horizontal, whatever value they give us, we've got to flip it. So if they give us 1/2 for horizontal, we've got to flip it to 2. If they give us 3, we got to flip it to 1/3. Whatever the value of the horizontal stretch and shrink that they provide for us, we have to flip it. And these are the ones that we have. And again, when applying these transformations, it's going to be very helpful to stick with these general forms for whichever one that we're doing or applying to the function. So we look at this first one here where we left off with, we're given the function f of x equals the absolute value of x minus 3. And we want to apply a vertical shrink by a factor of 1/3. Now at the top, they told us we want to name the function g. So we're saying g of x is equal to. Now our vertical shrink, vertical stretch or shrink is af of x, where a is the amount that we're stretching or shrinking the function by. Now they told us in this here that we have a vertical shrink of 1/3. So the value of a is 1/3. With vertical stretch or shrink, it's going to be exactly what it is. Vertical, it's exactly what it is. Horizontal, we have to flip it. Questions on this here? Yes. So A is going to be the amount that we stretch or shrink the function by. So if it's vertical stretch or shrink, A is going to be the amount that we stretch or shrink it by. Now, if it's horizontal stretch or shrink, we have to flip it to get our value of A. Questions? All right, guys. So, when we look at this here, what does it tell us the transformation is? Vertical shrink, yes? So general form is AF of x. And that's all we did for the first step. Because the new form, the new name we're giving it, g of x, that's just one they told us, is equal to a times f of x. A times the function we're starting with. Now the value of a is always going to be whatever we're stretching or shrinking the function by, that amount. So a in this case is 1/3. Our next step is just to plug in the value of a. We're replacing a with its value. So we get 1/3 times f of x. Questions on this so far? Okay. Our next step is we actually need to apply the function. Because what does f of x equal? So f of x equals absolute value of x minus 3, the whole thing. Now, since we still just have f of x, what's inside there is still x. We just replace it with its function. We don't have to do anything to it. So we still have g of x. We still have the 1/3. But instead of f of x, we're going to put the absolute value of x minus 3. We're going to put what it's equal to. Questions on what we've done so far? Now, the last thing we need to do is simplify. I need to apply this 1/3 to every term inside the parentheses. Now, our 1/3 times the absolute value of x. 1/3 times the absolute value of x. We're not going to multiply through what's inside the absolute value. It just goes right in front. Now, the other thing we have to do is 1/3 times negative 3. One-third times negative 3. Negative 1. And that's it. So the biggest thing with all these here is just stick to these general forms for when you're applying one transformation or the next. Questions on this here? We're going to look at one more with horizontal translation. I don't think this one's in your note sheet.
Oh, no.
No. So y'all can watch this one here, because here, if we're looking at this, because I think doing one more of these is going to be helpful. All right. So we're going to look at this one here. Now, this one isn't in your notes, but we're going to go on and look at it. Now, this one here, we have what kind of transformation? Horizontal stretch. Now, the general form for horizontal stretch, as we have over here, is f parentheses a times x close parentheses, f of a times x. That's the general form for this here, for applying this transformation. Now, the problem told us we're going to name it g of x. Now, the way we name it's not the biggest point or biggest part of this. We just need to give it a name. Now, the factor of the horizontal stretch is given to us as 2. But before we can use it or find its value of a, we have to flip it. 1/2 or 1/2 would be our value of a. Horizontal stretch or shrink. This is the only one we have to actually do anything to it. Because left, right are horizontal translations. If it's to the left, it's -4. That's our value we'll plug in for h. Up, down, if it's going up 2, we're plugging in k as +2. Vertical stretch or shrink. Whatever that value is, we just plug it in. Because if it's bigger than 1, it's a stretch for vertical. If it's between 0 and 1, it's a shrink for vertical. So here, this is the only one we really have to do anything to, and we flip it. And the next main thing is we're just going to replace a with its value. So a is 1/2. So we're going to replace a with 1/2. Questions on how we got to this point here? So the last one we had f of x, and we could replace it with its function, yes? Here do we have f of x? Well, no, what do we have? F of ax, yes, which became 1/2 x. So we don't have f of x anymore. We have f of 1/2 x, yes? Well, our first one said f of x was 4x plus 2. We took this x here and replaced it with 1/2 x, yes? Which means every x over here is going to have to be replaced with 1/2 x. We replace the one, we've got to replace the other. So for us here, when we do that replacement, we still have the 4, but instead of x, we have 1/2 x plus 2. The x's change, everything else doesn't. We still have the 4. Instead of x, we have 1/2 x. And we still have the plus 2. Now, the only thing we really need to simplify is our 4 times 1/2 x. 4 times 1/2 is indeed 2. X plus 2. It's very easy to do. Questions on any of this here? We feel good with this so far. We're ready to do multiple transformations. Okay, we're ready for multiple transformations. Combining transformation lets the graph of G be a vertical shrink by a factor of 0.25, followed by a transformation 3 units up as a graph of f of x equals x. We want to write a rule for G. So G of x is what they want the final one to be. Whenever we do multiple transformations, we're going to do them one at a time in the order that they're listed. So the first one we have is a vertical shrink of 0.25, followed by station 3 units up. So we have 2 of them. Now it is possible to do them all at once, but again, it's easier to do these one at a time. Now we do need to name the one that we're going to do first, because it's vertical shrink. So someone give me a letter. H, we'll do W for the next one. So H of x. Now the reason we're not calling it G of x is because G of x is going to be the final one, the final function, name of the final function. So H of x. So the first one we're applying is a vertical shrink. What's our general form for vertical shrink? AF of x, yes? Okay. AF of x. H of x and f of x are just ways to name our functions. h of x has not been defined yet because it's the function that we will get from applying the vertical shrink by a factor of 0.25. F of x has already been defined. It is equal to x. Because when we talk about f of x for this here, we're talking about it being equal to x. Questions? Better to see? All right. Questions on this so far? Now, what is our value of A? A is 0.25. Since it's vertical shrink, we don't have to do it. It's no changing. The only one we need to change is horizontal. Our next step is just to replace A with its value. So that'd be 0.25. F of x. Now, unlike the last one, do we still have f of x? No. So, all we have to do for this one is just replace it with what it's equal to, which is just x. We ready for the next step? We multiply them together, yes? And 0.25 times x is 0.25x. Okay, well, vertical shrink by a factor of 0.25 done. Well, that's essentially what we've done up to this point, yes? Because that's what we've been doing. But on all the other problems, that's where we were finished. We finished at that point. But now we're going to apply a translation of 3 units up, yes? So, and this is the final transformation. So we'll call this next one g of x. Now our 3 units up would be a vertical translation. Up and down is vertical. So we would, in the general form, have f of x plus k, yes? Are we applying it to f of x this time? We're applying it to what? Because we're applying this to our, this h of x is 0.25, yes? So we ready? So we're going to say it is h of x plus k. Because again, we've been using f of x because we've been applying all these transformations to the function f of x. So that's why we used f of x. But this one we're applying it to h of x. So again, f of x, h of x, any of these here are just a way to name it. What are we applying it to? Now for us here, our value of k is going to be 3. And it would be positive or negative? Positive because we're going up, so it's positive 3. So over here, we're going to place k with our positive 3. So we have f g of x equals h of x plus 3. So now we need to, well, before we move on, are we good with getting to this point here? So now we need to plug in our h of x function. We still have h of x, so it's just 0.25x. Is there anything in front of our parentheses with our 0.25x? No. So we can just drop them. And that's it. Questions on this here? So really, this is the same thing as what we did before. We just did one and then applied another one to it. Because at this point, if we wanted to apply a horizontal translation left to right, we would just apply it to the one here. Questions on any of this so far? Are we ready for the next one? Let the graph of G be a translation of 6 units down, followed by a reflection in the x-axis of the graph of f of x equals the absolute value of x. Write a rule for G. Find the equation. That's all it's mean. Write a rule for it. Find the equation for it. So, we're going to start off with Wx. Is our first transformation is 6 units down. And the second one is a reflection in the x-axis.
Because that's what you said earlier.
Yeah.
You said it earlier. There's nothing special.
There's nothing special. Because I asked for a letter in the previous one. Dara? No. Dara. I'm getting there. We're going to get there. And Jose said W. So that's all I picked. Because especially on the homework, if it says G of X and you decide to use W of X, that's fine. I'm going to be looking more at the function than what the name is. Because again, it's just how we want to name it. And I'm more, especially on this assignment, seeing can you apply the transformations, not can you follow what it says naming-wise. I'm more interested in the function, not what did you name it. So if we look at this here, we have a translation of 6 units down. That's, again, vertical translation. Applying it to f of x, so this would be f of x plus k, where k is our movement up or down. And how far are we going up or down?
6 down.
So 6 down, so k would be -6. Left and right, if it said left 6, h would be -6. If it said right 6, h would be +6. We don't have to change anything with that. The only one that we're applying it to a function that we have to change or do something is horizontal stretch or shrink. That's the only one we have to do that with. W of x is equal to f of x minus 6, because we plug in the value for k. Because we could put it in as plus -6, but we don't ever write plus -6. We just write -6. Questions on this so far? Yes. Now, since we still have our f of x, we can just replace it with what it's equal to. Yeah, since there's nothing in front of the absolute value, or in front of the parentheses, we can drop them, telling us that our translation 6 units down will give us the absolute value of x minus 6. So any questions on our first? So that first one's done. So reflection in the x-axis. Reflection in the x-axis. So the ones that we have written on the board, reflection in the x-axis would be negative f of x. But since we're not applying it to f of x, we're applying it to w of x, it would be negative w of x. Questions on this here? Still have the negative. But with w of x, what's inside that parentheses next to w is still just x, yes? We don't have 2x like or 1/2 x like the one before. So for w of x, we would just replace it with absolute value of x minus 6. So really, sometimes confusing, all we did was we took the function w of x and replaced every x in it with x. So it looks the exact same. It doesn't really change anything. And the last thing we have to do is distribute the negative. Now the negative will not go inside our absolute value, so it's just going to be negative absolute value of x. And our negative 6 would become plus 6. And that's it. Questions on this here? We feel good with these here? Does the order matter for how we apply these?
Yes.
Let's see. So y'all don't have to write this one down. I'm going to do this one again, but I'm going to switch the order. So I'm going to apply the reflection across the x-axis first. So negative f of x. Well, that's just going to be, we'll replace f of x with its function, multiply it. So w of x is negative absolute value of x, because that's what we ended up with, right? All right. Translation of 6 units down. So that would tell us that our g of x is equal to w of x plus k. We already said our k value is negative 6, so we'll plug it in. Now at this point here, we'll replace w of x with its function. And we can drop the parentheses, giving us that g of x is equal to negative absolute value of x minus 6. Is that the same function? Not quite, because here the 6 is negative, and the one that we had before the 6 was. So the order does matter, especially with up, down, left, right, especially if we're doing them in either order. Because if we flipped the one before and did the translation up before the vertical shrink, the function we would have gotten was 0.25x plus 0.75, because we would have had the other one that had to apply to it. But order matters for these here. And luckily, it's not something you have to worry too much about as long as you follow the order that they're listed. Do it in the order that they're listed, and you'll get the right function. Does that make sense? It's kind of the same, along the same lines as the issues with order of operations. If you get them out of order, it's going to make things completely different.